Okay, this concludes the battery bank install and wiring. As you can see, I've got my inverter on there now, and it's all buttoned up, tucked inside. Everything is wired in good, and the only thing I need to do at this point is to hook up my power strip to it and install that and push it back in the hole and install my ice maker on the corner over here, and that should finish this section of the van up. But alright, now what you do is you strip them wires back, leave the coating just long enough just to go inside your terminal. Okay, round two. Now we're making the battery terminal. Taking half-inch large copper. This is 0-aught wire, or 1-aught wire, I'm sorry. And we're going to make the battery terminals. And what we're doing is we're making the jumpers go to crisscross between the batteries to tie them together. The shorter the wire, the less heat up they have. And that's why you want to do that. And you always want to tie your battery bank as beefy as you possibly can. That way you don't have any kind of drop or heat up problem inside the batteries. And this is one that we've tested to make, and this is how it will look. So we smash it down in a vise and then hammer it, and then we flux it and solder it, and we put solder all down inside of it. That way it makes a nice, and drill the hole for your bolt to go through. And then we'll probably come over the end here and lap back over with some heat shrink. And that should keep the batteries pretty well taut and secure. And then I'll probably just use either colored heat shrink, or I'll identify which ones are red and which ones are black. And then that's the way we'll be able to build our batteries.
Grab that, Jim.
But to do that, you're looking at $4 for a piece of pipe versus $2.11 per terminal end. So that's $4 per wire to buy just the proper ends that they sell already manufactured. So this is how we save money when we do our build. And remember, get it on down in here some.
Yeah, you want this to the end here.
Yeah, I want that crimp pretty thick here.
Yeah,
so
I know
want it
that.
to stick past that battery terminal.
I'm just getting it so it don't move.
And yeah, really push down. I might have to do that for you.
Yeah, I just want to get ends on it.
There you go. And then we'll build those up. So we'll stop here and I'll come back and continue back. Okay, now this one is we're soldering all the terminals that we made onto the wires. Gives a nice, good, solid connection.
When this turns blue, I know it's enough.
Yep. You want this to run down in there pretty good.
Okay.
Just feed that down in there. Just keep letting it feed. Fill that cavity up with a better connection. Alright, that's good one. Alright, take it up. Okay. You want to pop this loose for me?
Tell them to stand back.
Now you just stand back because it's going to splat at you, but you want to smash this as flat as you can. Now that sucker's on there. Okay, now this is your batteries here. I've got 4 of these EverStart batteries. That's 135 amp hour, 1000 amp cranking power. They're deep cycle batteries. You have positive, and negative to negative. Now you see how I turned both the batteries inward? That way I can access the fill ports here on both sides without really interfering with any of the wires. So I should never have to take these apart. And then I got them crisscrossed all through all the 8 terminals. And now on the battery, when I go put my charger and my inverter on, I'll be pulling from this end of the battery to this end of the battery. So this will be my negative, and then this will be my positive on the full battery bank. That way it's pulling the power through the battery and pulling them all down equally, and when you do your power. And I'll show you more on that once once we start to weld those up. But I got to put a special end with all those cables on there, and that way I can get those hooked on and doing that in there, and then just tighten everything up. As you see, this is very, very high power. When we were putting this one on, this cable end flipped over and hit this, and it blowed this out. You can see how it burnt this out. So you got to be very, 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 very careful, because that will definitely destroy you. It'll hurt you big time. So be real careful. Now we're going to check this meter. You know, Warren, you're going to pull power from, take this one to this terminal, and that should give you 12 volts. Positive to the negative should bring it 12.63 volts. So I mean, now if you go on up to the next ones above it, you should have 12.63 volts. See, 12.63 volts. Now any combination of these batteries, you should have 12.63 volts too. So if you test each one of the batteries individually, you'll have 12 volts. That's how you know that you are in parallel. That is called parallel wiring. What you do when you do the parallel wiring, you maintain your voltage the same, but you double your amp hours. So I got 135, 135, 135, and 135 in my amp hours. So you would multiply that 135 by 4, and it keeps all the voltages to 12 volt. Now if you go to series, you would run them just loop from one side to the other. Negative to positive, negative, positive, negative, positive, negative, positive. And by doing that, then you would raise your voltage to 12, but you would cut your amp hours in half. So that's how you would figure out what you got there. But I am running in a parallel situation. My inverter is 12 volt inverter, and my charger is a 12 volt charger. And those will be wired up to where they charge across and through all the batteries. And then of course I'll also have the one that I put down in here. That's a whole different battery system altogether there. But this is the main battery system just strictly for the air conditioning unit itself. Okay, we'll talk to you soon.